We're talking today with Jason Lee. He's an agronomist and farm solutions specialist with AGCO. Jason, let's talk about the crop tour and crop care. What's going on with AGCO there? And I think you've got a special area you want to share with our growers today.
Yeah, absolutely. So the crop tour program has been in existence since 2016. And so we are in our fifth year with doing these educational field day events. And in the past, we've been really focused on everything that we need to do to optimize our planter performance to maximize crop yield. So focusing on the correct planting depth, correct seed singulation, and correct downforce settings. So now with our new FET Momentum planter and the load logic system, we are taking that one step further, and we're looking at how our planter can help manage compaction.
Tell me about load logic. What is that? It sounds fancy, and I think it is, but what would it be for a farmer?
So the load logic system is a feature on our new Momentum planter, and it really consists of two major components. One is a hydraulic weight transfer system that can automatically balance the weight out evenly across all of the tires. So when we think about central fill planters, we have all that weight centered right there on the center of that planter. With this hydraulic weight transfer system, we can spread that weight evenly out across the entire planter to help reduce compaction. Number two is it has an automated tire inflation system, which what that means is the system will automatically adjust the air pressure in the tires to help reduce surface compaction. So one of the easiest ways we can alleviate soil compaction is to have a lower air pressure in our tires. So when we have a lower air pressure, that spreads the footprint out of that tire, so the same weight is spread across more of an area, so we reduce compaction. So with the weight transfer system and with the tire inflation system, we're reducing compaction, and we're able, but it's important to remember, we're able to carry a heavy load and minimize the damage that we're doing to the soil. So we're still maintaining a high level of productivity, but we're just doing so in a way that we're not doing very much damage to the soils.
So if I were going to look for evidence of compaction in my cornfield, what would I look for? What's the crop care tour going to show me? What would I see?
So we're looking at a lot of different things, and there's a lot of different ways to diagnose compaction. One of the easiest ways is crop height. And so what compaction will do is it will restrict root growth below ground, right? And that's obviously going to have an impact on what we see above ground. And so anytime I restrict my root development, I'm obviously going to restrict my above ground growth as well. So anytime we see stunted plant height, that can be a very obvious symptom of compaction.
Great. So we're going to see all those details during the virtual crop tour. It's very exciting. It's been good to talk to you, Jason Lee with AGCO.
Absolutely. We're excited to share the yield results this year. So stay tuned.
Hi, this is Willie Vogt with the Farm Progress Virtual Experience. Welcome to our breakout today on looking at planter technologies and maybe considering whether it's time to either upgrade or buy a new planter. Today, I'm happy to bring along with me AJ Sharda from Kansas State University, who's doing a great deal of work with planters in the field and actual yield and field conditions with all types of new planter technologies. AJ, welcome to the breakout.
Thank you, Willie. Thank you so much. Appreciate it. Happy to be here.
Great. I think what we're going to do today is something a little different. We're going to kind of have a dialogue and go through some of the work that you've been doing, but why don't you start us off? What should I be looking at with my planter today? And even whether I've got a current planter or I'm looking at a new planter, what are some of the things you're finding out?
Well, if, you know, from my standpoint, from our standpoint, people who are working in the planter world, what every farmer should be looking at is that there are two basic needs from planting standpoint. I want to have the right population in terms of seed put in the ground with good spacing. And I want to achieve good seeding depth, which is consistent all along. These two things are going to give me good emergence, good, stand, the population aspect of it. Three things which everybody should be looking at. One is the row meter performance. Like, are my meters running at the right RPM with respect to the ground speed of each individual row unit? We are not going to talk about the toolbar because we are seeing more and more 16 row. And I teach the course, and I ask my students, they are seeing more and more 24 row planters as well. So if I go wider on my toolbar, forget about the whole toolbar, we want to go now on a row by row basis. So every row's speed and its meter RPM should be respective of that, so that I can maintain the amount of seed I want to put in for that individual row unit. Second thing is the singulation capability, that unit should be able to singulate irrespective of speed, a little bit bumps and all that stuff. So I don't want to make too many skips, too many doubles, but singulation all the time. So all my settings, whether it is the vacuum, all the hydraulics part, the knockers and all that. And then the third most important aspect is the component of downforce. You've seen some pneumatic systems coming early, but every company has moved to the hydraulic downforce systems. We are not even seeing sections. When we thought like section is going to be the coolest thing. Who's going to put money for individual row and sensors? Heck, we are here in 4 years. Every system now is individual row downforce control, right? So all the narrative of a lot of money and all that. And then what is this going to give you is consistent, good load on your gauge wheels, good seat to sole contact. That relates to that I will always have sufficient load available on my row unit to be available to opening discs, to open up the trench at the right depth and put the seat at the right depth. Less vibrations, or what you call as row unit acceleration or ride quality, which again means that I will have less variability in my seating depth. I will have less ricocheting effect if I have mechanical seat tubes, so my spacing will be tight. So having a good downforce system does a lot of good things, in terms of not only putting the seat in the right depth and placement, but giving the right environment to grow.
Would you put that as the first place you'd look? If I'm looking at my current planter, I've got a 24-year-old planter and it's got maybe old spring type downforce or maybe even pneumatic. Would this be the first place you'd look at for upgrading, is to see about putting on a hydraulic downforce system?
I would definitely agree with you. And we can debate on both things, whether the electric seat meters are downforce, but I think downforce has much more important role to play, especially when I am running those wider toolbars. I'm going across the field, all the terraces, little hills, all the soil variability aspect of it, moisture variability aspect of it, and the aspect of crop residue, kind of crop I've left in the field, root balls and all that. So all those things starts to impact quite a bit, because we can go back and we can spend some time there. But from spring perspective, and trust me, they are great system, but they cannot manage the variability within the field. And we know that based on the soil variability, the terrain, the moisture and all that, you will need a different level of load on the row unit for your opening disc to consistently operate at the seating depth.
So the reason I asked the question is because with $3 corn, I might be able to do one thing a year. So right. Maybe this is the year I look at downforce for my 2021 planting season, and maybe 2022, I look at electric meters, or vice versa. But I'm wondering if maybe downforce may be the better initial payoff, because I may not want to run any faster, but downforce can get me a bigger deal. And you made a good comment. 5 years ago, we were all like, it's going to be sections. It's not going to be individual rows. Hydraulic downforce and electronic control allowed us to ask a question we couldn't ask before. Now, you've been looking at downforce in your work. What have you seen with these hydraulic downforce systems? What benefit have you actually seen in your work at K-State?
So let's jump forward, feed forward here. So I first quickly want to give a quick speech on that. We started with some work between comparing our fixed downforce systems versus active hydraulic downforce control system. And this study is particularly with sections because, 5 years ago when we started around 2015, 16, we have section controls, right?
Right.
What we quickly learned is that there's significant row-to-row gauge wheel load variability if you are using a fixed downforce control system. You not be on the consistent load all along. The second most important thing we learned is that we were measuring our gauge wheel loads for each row. Then what we did, we started combining those row units together to see that, can I work with a section, control section or not? So we started with, 4 row sections and 3 row sections and 2 row sections. We quickly come to know that based on the row to row gauge wheel load variability, the smaller the section, the better you are, because the variability between the 4 row units which are operating side by side is wide enough to satisfy everybody's need. Your range is, somewhere between 200 to 300 pounds at any given time. So how do you satisfy somebody who is too low and too high to get to an average value? We also looked at the difference between tire tracks and no tire tracks, and we are learning more and more based on our study in these years, is that there is definitely difference in terms of how we would like to manage our track rows because of the compaction happening. Soil is a major factor from that standpoint, but the biggest learning was that an average of 20%, normally they are more than 20%, but average of 20% of the field was planted with less than 0 gauge wheel. So what does this mean really to you if you have a 0 load in your system? That means I have no idea if my gauge wheel loads were touching or they were an inch above the soil, or so those are the conditions where my seeding depth will be completely unknown. I have no idea whether I put it on the soil or an inch shallower or half inch shallower. So just this part was the biggest thing from people to realize. And this study, was one of our very first studies. We have few fields which were 35, 40 acre fields and few which were 60 acre field. So the point I'm trying to make here is that even very small fields, you will be seeing the kind of variability you may not expect in your fields.
Well, 20% with no pounds on the gauge wheel. I mean, that's seed floating on top of the ground. Maybe.
Exactly.
I mean,
maybe. Exactly.
We know that's a problem. Yeah.
Right. So that's one. And then we are doing a lot of work in terms of the active downforce control, couple of years. And we have really focused on, we have shifted our focus on looking at different rows in terms of how they operate. So we are focusing to see, what our wing sections are doing, which are, marked in the red, triangle, which are my outer rows. How my track sections are doing, which are following tire tracks and tractor tracks and planter toolbar, and how are my non-track sections are doing, which are seeing, which have good downforce and also which are not facing any compaction. So again, coming back to the same thing, that I'm really trying to optimize row by row yield and row by row performance in terms of where my planter toolbar is. So to quickly give you, for today's discussion, we have upwards of 4,000 acres of data, and all farm level field sizes anywhere between 60 to 130, 40 acres. All type of terrains you can think about: cover, no cover crops, everything no-till. So this is one example from last year. And you can see the top plot shows you something about the soil EC, the kind of variability you might, we have speed, we have terrain. But here is one example of the gauge wheel loads, right? And we will talk about only 2 things here, just to see what things are going from a row to row standpoint. Now, if you see here, most of the field was planted with a target gauge wheel load of 120 pounds. So I wanted to be in that light green zone most of the time. I also want to emphasize that this is not a 2-second smoothened or 1-second smooth data. This is 10 Hertz data. So that means I'm taking data points 10 times a second. So I stayed in my zone most of the time. You might notice I have here dark, green sections. So this was our test trips where we were looking at 220 pounds of, gauge wheel load, right? So I was able to do that as well. Now, the biggest testament of some of this thing is we were also measuring the hydraulic pressure, right? So some people can see but they cannot see, okay, so what are we talking about? Are we talking about like, 100 more pounds or 200 more pounds? AJ, come on, how does it matter? Oh, give me a break and all. So you can see that up this northwest section, this curve, this is the hardest, there used to be a brick kiln here. So trucks and things used to go in and out 20 years ago, and that compaction is still showing in the field. Right. So I was amazed that everything else in the field is good. And then we talked to the farmer last year when we were looking at the data. He said, like, this was a condition. I'm surprised we still have compaction there. So you can see that in general, we were between 6 to 900 psi hydraulic pressure, and we went all the way to more than 1,500 pounds. So what does it mean? That if I do not have my active or hydraulic systems, I will be shallow. Absolutely no doubt about it, because I do not have the load I need to give to my opening disc to get to my seed trench. Make sense?
Yes, it makes perfect sense. And it's an area we don't always think about. I mean, it does mean getting off the planter and walking behind it, right? I mean, that's the one way you can find out what you're doing is if you've got an area that always seems to have a bad stand, you should be behind that planter, right? And looking at what's going on.
Right. One more thing I want to say, Willie, just to emphasize this thing is, so like I mentioned that we are trying different gauge wheel loads or target gauge wheel loads, what we want to manage. When we started 4 or 5 years ago, most of the, even up to last 2018 as well, when we used to talk about, there is no set recommendation. If you ask a manufacturer or a tech guy, so where should I start? There's always a little bit of a, kind of a guesswork, where do you start? And even from that standpoint, when we said that we want to do 200, 100 and 220 pounds, people say, oh, no. 220 pounds is way a lot. You're definitely gonna get compaction. We'll see some, late emergence and all that stuff. But just in the last, as we are sharing more and more information with, people we work with, and during our programs, we have now come that I was surprised. I don't want to take anybody's name, but the same guy came in and I was talking, so what gauge will you say? Well, we are suggesting somewhere around 150, 160 to start with. I said, like, that's a good start to have. So that is one more narrative we kind of, people who are working and we would like to say that we are helping in that, area as well. But see what happens. So this is my row unit acceleration, Billy. And you see that I have those triangles are my non-track, my circles are track, and my wings are those squares. So I have the most row unit bounce on my wings, which is kind of expected, right? So
they tend to flex,
right, a little bit, yeah. And this is a 16 row planter. Talk about a 24 row or a bigger planter. How do you transfer weight? And now we have seen that people have started using additional hydraulics to transfer some weight onto the wings. But the way planters are developed, the middle rows have all the leverage to do the weight transfer onto them. And as you start to move out and out on the toolbar, your ability to get that weight transfer rapidly and just enough starts to go down unless you don't have additional components built on that. But that tells a little bit more about it, but again, there is a variability, but you don't have to worry about it. We are just under a G, which is nothing in terms of your unit bounce. You go around, you go behind your, planter, planting at 6 miles, and you have mechanical spring. You can hear that chatter going on, of your row unit bouncing all the time. And I'm just want to emphasize this 6, 7.5, and 10 is my planting speed. So we are not even talking about 5 miles. In this presentation or in this talk and everywhere we go, we request farmers to give it a shot. If you invest in a technology like that, we request you to trust it and go a little bit beyond then or a bit further than what you typically do, because we believe that it will give you what you would expect.
So basically, though, these are very responsive systems that you're working with. These downforce systems, these hydraulic downforce systems, no matter the brand, they are really responsive.
They are really responsive. Absolutely. And I agree with you that as well. There may be slight variation, of, somebody's here or somebody's there, but so long you have a hydraulic downforce control system, all these systems will be pretty responsive. Yes.
Well, let's turn our attention to the other area that people talk about all the time, and that would be the electric meter.
Can we?
And the value of that? I mean, is that something I want to upgrade, or is that something I want to have on my next planter?
Absolutely. And can I just show one more?
Yeah, absolutely. We can talk here first. Yes.
So I really want to show people that this was my seed spacing, which is all consistent, and this is what somebody will expect. But what I want to show people is my seeding depth. When I was driving at, I was like 6, 7.5, and 10 miles. So if you have the right downforce, which I would be using 220 pounds for this field, you can see that I was at 2-inch and I'm still under 1/4 inch variability, even when I'm going at 10 miles per hour. That's the kind of confidence you can expect if you have the right system and also have set your technology right. So you can do 120 pounds. They're going to be decent, but as you go faster and faster, those row units are going to start to ride outside, because of all the rolling resistance and their ability just, don't have enough loading on them. But if you have it, this is pretty flat. And I'm talking 10 miles. At 10 miles, Willie, you won't be able to recognize where your row units are because there is so much soil movement and residue movement is going on. It's looked like a tillage treatment once the pass is done.
Wow. That's amazing. But that 220 pounds kept it in a nice, within a 1/4 inch zone on seed. That's going to give you such consistent emergence. And we all know consistent emergence is what we're supposed to be targeting, right?
Right. And I want to, we don't have a lot of time today, but I can tell you from last 5 years, everything, if everything is done right the way this is, everything emerges within 3 days. So 95+% emergence is within 3 days. There's only a plant or two left here and there. And I want to share something here.
Yeah.
That, our guys go out and we check right after planting, by digging the soil. And I can tell you over years, we have seen that 220 pounds. Yes, there could be soil conditions like that, but if you are in decently, and 220 may not be enough in some of the rough conditions if you go to Western Kansas and I have bigger root balls and more done and drier soils. But in this area where we are, in and around Manhattan, good pliable soils, good residue, kind of a medium to heavy soils. We check, we have never seen anything like compaction on my sidewall. We go out and you can see this picture. This is the picture of my second day, and 90% of the plants are out on this one. We check the moisture content, we go back spacing, and we also go back and look at the stage uniformity. I think that is one of the very important things people should be looking at. So stage uniformity is that I want to go back at V6 stage or V8 stage. And if a plant has come out a day early or a day before than everybody else, what happens at V6 or V7 stage? If everything has caught up, then even if there is a 4-day window, hey, I'm fine. So this is what we want to tell people, that 4-day window is absolutely agreeable. It's within the margin of what agronomist says. We dug out roots this year from our 120 and 220 downforce. There is absolutely no difference in terms of root structure as well. Same around. We had doubts in our minds as well, because sometimes you think that if everybody's saying maybe something is wrong. So this year, what we have done, we went out and we dug roots from our different treatments, different soils, we didn't find any difference in terms of soil, root structure. Yes.
I guess people just don't think of downforce. They think about it, but they think they've been doing a good job. So what's the big deal? But now you're learning that it is a big deal.
It is a big deal. And you have seen that different rows might be needing something different, based on where they are. And, compaction is happening in terms of, we need to set if we have a good system, which there are a lot of good systems available outside. And if we set it right, so here are a few examples. You can comfortably drive up to 7-8 miles and you will get exactly same results what you are achieving at 5 miles.
So before we move on to electric meters real quick, does that mean that it should be more weight on the wings and less weight in the middle, or what are you seeing? Or do you just stay at 220 across the bar as a range?
So here is great question. I'm glad you asked this question. Right now, what we have is that our control system only needs one number.
Oh.
So I cannot set different numbers for different, row units. This is something for people to consider as we are talking, is that should we have within the screen some setting for my track rows and a different setting for my non-track and a different for wings so that I can manage that? Or what other now companies are offering, additional hydraulic cylinders, which are actually putting extra, they're adding some more load on there, taking from the center, putting on the wings. So
yeah, they're using the downforce to kind of bring up the planter, right? So level the planter for that pinch roll compaction in the middle. Yeah,
right.
We see that.
So great question. And what happens is that, if we need more, we may not need a lot more in the middle. We may need a little bit extra on the wings. Right now, we don't have capability to set it differently. I just set it fixed down for what is my target gauge wheel, one number for everyone.
Okay. But you're getting that consistent emergence and you're getting consistent planter depth.
Exactly.
So I would be happy with those numbers based on what you're showing.
So far, we are pretty good. There is very little, there are some differences like we have seen in the wings, but not too much.
Well, let's talk about electric meters because that's been all the talk in planters the last few years. It's allowed us to go faster.
Right.
You had talked about this as an area, but what is the value of this? I know you've been working with electric meters for the last few years. What are you really seeing? I mean, we've had mechanical planters a long time. What do I get out of an electric meter?
So I would take this slide right away from there.
Okay.
I think what electric meter has done is that I would term them as the first entity which has converted our 16 row or a 24 row planters to 16 or 24 1 row planters.
Oh.
With the electric seed meters come the row control module, which is my little, brain sitting on each row unit. It exactly knows. So my ECU knows where my rows are and what speed they are going, and individually commands that row unit to run at that seed meter to run at a specific RPM. So what it is doing is that it is taking care of all the row units, not from a toolbar standpoint, but from a row by row standpoint. That's number one. Second thing is, since I'm controlling everything on the row itself, the response is rapid. It's not that hydraulic system is sitting somewhere, I change the hydraulic PWM control, then all the travel and all the, shafts and gears and sprockets and worm gear and all that stuff. It is right there. The only thing is there's an electric motor, there's a gearbox and shaft and my disc. Everything is all together. I can jam it, change it, instantly, means in a very, very short amount of time. I'm talking about less than half a second. Third thing is it gives me an opportunity to do section control by default. I just have to say, don't go anywhere. Just stop, right? It's no extra effort, no extra components. My variable rate seeding becomes more easy because now I can tell anybody to move at any speed. I have full control on what I'm doing. And I saved the best for the last, which is my turn compensation, that I can control when I'm planting on contours. Really, how many fields we see? We go to fields, we see fields which have contours or terraces, and people would like to plant along them or and then tight turns, irregular shape, field boundaries and all that. And that is, I think, another bigger component, because if I can maintain consistency of seed spacing all the time, that's great. So all these packages come by default. And also on top of it, your ability to rapidly transition from one speed to another and being at the right meter RPM, right? We talk about the meter RPM because meter RPM are maintaining your population based on the speed. And I can show you, so you can see numbers here. This is a field, this is a lab data, but we used some high-speed imaging. We collected upward of 2 million images. We developed some, image analysis program and all that to create all these speed transitions. And every test was a couple of acres in terms of lots of seeds movement thing. So we stayed upward of 98.5 most of the time, right? 98.5 to 99. I think that's a pretty good simulation from that standpoint. And it will stay good if I have a good downforce system as well, because it's not going to let my row unit bounce a lot, right? So, so this is where we are. And this is one example of, I brought an example where if the planter was on a contour, there are few, I just selected few row units, row unit 4, 7, 15, and 24. But you can see that every row unit its meter is moving at a different RPM based on its own speed, right? And I was transitioning, and then when I'm at 9 miles per hour planting, everything merged together, and I was exactly where I wanted to, because the dotted lines are where I want to be. The solid lines are the dotted lines are my actual RPM, and my solid line is what I want to be. You will see that there is some lag when I'm transitioning, because it's a responsive system, but the RPM is always within 2 to 3 RPM. It is catching up really, really quick. So
basically, if I can swing it and my planter bar is in good shape, I should be looking at both electric meters and downforce. Or if it's too much, maybe I should just look for a new planter, because some of these new planters are also built to go faster because of the way they're constructed. If you want to really go 9 miles an hour, you could do it with an older toolbar, but it would be something I would talk to my dealer about. And
absolutely,
speaking of speed, you've got a new project. We're about to wrap up here. You've got a new project that you're going to engage in for 2021. It's kind of exciting, right?
Yes.
I know you talked about turn compensation. Let's finish with that, and then we'll go to the new project. But
right.
I get turn compensation with my electric meters, right? That comes with it.
Yes. Very quick. I won't take more than 30 seconds. But the reason I'm saying is there are not too many studies out there. The documentation is very little, and we sometimes think that we're not planning too much area. So here is one quick example. It's not a very regular field. This is 2020 data, and just looking at all these red marks show that you were planting where the planter was having some sort of a turn going on. So if you are planting anywhere between 15 to 25% of the field with some sort of a turn compensation going on, I think it is worth thinking again or considering, what do I need to have to get my right population? So here is
it makes sense. Good, clean singulation, maximize solar energy. Right. Don't get your spacings wrong. It's all things you need to think about to get more corn out of the field. Definitely.
Right. Exactly.
All right. Let's talk about that last project. I'm excited about this for 2021. What are you up to?
So we've been doing some of the work, but couple of things we want to achieve. This is a project funded by the USDA NIFA under the program called Critical Ag Research and Extension. So this project has to have a research component, but also a very heavy extension component. What we want to do, some of these things in this thing is, we want to now reach out to some of the farmers. We have already developed a survey. We are just finalizing, and we're going to release it to the online audience, and some to the audience. We will be doing all the corn and soybean schools this year. But beyond that, we really want to hash down the process of selecting the right downforce for yourself. And we are going to emphasize more and more on yield benefits. What is the yield advantage you can get from fixed versus active downforce control systems, right? And because what people ask us all the time is that, okay, I want to invest on that, what do I gain? And I split that into two components. One is that if you can drive or move your sprayers from instead of 5 to 6 to 7 and 8, you have a right advantage upfront to cover more acres in a smaller window of time available for planting. That's the number one thing you would not have been able to do if you do not have the right plan. But the second thing is we have seen there is a definite yield advantage. From our very limited data, we are somewhere between 3 to 5 bushel, but we want to do more and more large scale field studies where we want to understand the difference between fixed and active, like what kind of a yield advantage you can get. I don't know really where you stand, I know the other people, but if I can see even a 5 bushel difference, I think in this time and age, that's going to be a good bit of money to start thinking about, okay, I have now a 2 year of payback, or for people who plant more, maybe a year of payback in terms of my investment. That's the thing. So overall, we want to really develop a lot of best management practices for farmers in terms of how to use these systems. We want to tell why you should be using these systems, what are the advantage, and then what is the economic benefit you can gain from that by having a system like that.
I think it's going to be good to look into. Well, AJ, it's been great talking to you today. Why don't you put up your contact slide to let everybody know where they can find you? I know you're really responsive on email, and I appreciate that. And you've got a lot of work on precision ag on the website for KSU. Well, for those who've been watching this presentation, now that it's live, you can come back and watch it at any time. And we appreciate you being a part of the Farm Progress Virtual Experience. AJ Sharda from Kansas State University, thanks for being our guest on this planter breakout. I look forward to checking in with you next year on this research and what you're doing with farmers to learn more. Heck, we might have to do another session. I appreciate your time and have a great day.
Thank you, Willie. Thank you so much. Appreciate it.